Hey guys, what's up? Welcome back to these new sections. In these new sections, we will have basically three parts. We are on the first part, and in the first part, we have four questions. So this will easily take like 1 and 1.5 week to complete because I have other works to do as well. So one day, one question we'll try and deal. And okay, today's task is basically how can you implement a function called same frequency that checks if two numbers have the same frequency of digits. Let me just break it down for you. For example, um, it will take two numbers, number 1 and number 2. It will return true only when the frequency of the digits in individual are compared with the another individual number and they match. In that case it will return true. So we have done similar kind of things, but with I think strings we have done it, but we have not done it with numbers. But we can do that with numbers as well. And in my brain, I'll be honest, I'll pause this video. For example, look here, like 1 2 3 4 5 6 0, 1 2 3 0 4 5 6. So basically they both have similar, they both have same number of digits. Yeah, that is true. They both have same digits. Yeah, that is also true. The number of digits repeating in both of them is also same, that is one only, all of repeated just one time, but they are arranged in a similar way. So anagrams, basically anagrams for numbers we are trying to find. Kind of heartbeat is racing because my brain is unable to come up with a solution, not even a nice solution, but I'll pause and I'll try without actually looking into the solution. I might even use my rough copy, you understand, right? A rough page. Like what is a rough page? Like a, you know what I mean, right? Like random page you can write things on, and you can use your anything surroundings where you can just basically let's come up with a solution. Okay, I am back. Okay, you might be thinking I just did ChatGPT. No, I just wrote the entire code on my own, and as expected, I could almost get it done correctly, but I was having a struggle with. This was my question basically. Um, we added a short circuit also at the beginning. I'll show all of this in the more formatted code so that you can understand like what is what. But my question was that when we take in the inputs n, or like num1 or num2, in that case, like, do we need to stringify the number to make it iterable, or can we use it directly? So answer was we have to stringify them. So yeah, I'll show you how it is going to work out. As well as I was having a problem uh, in the final after you have created the frequency counters for two of the iterables. Now you want to use a logic to filter out that the frequency is matching in both of them or not. Same frequency is there. The frequency could be matched on two bases, right? The first is like, okay, that certain key should have a certain value. Think with me. A certain should have key should be common, right? Key must be common in both of them, right? That we have understood, that we are assuming. And the thing is, it should have a same value. What does it mean? It should have a same value. That means if 3 is like 2 times in one number, that it should be 2 times in another number. That was easily done. So we just implemented the logic here. It was easy. But we missed on one logic, that is, what if there is a number inside it which is not present in one of the numbers? Like the length is same, okay? But the thing is, for example, 5 was 5 was there in number one, but 5 was not there in number two, for example. So if you don't put that logic, which I'll be showing you, it might not work. So I mean, I was almost easily able to do it. It's just like anagrams for numbers, by the way. Okay, I was feeling nervous and I'm still feeling nervous. Okay, let me just show you the code. So define two variables string num1 num2, which will basically stringify the numbers. I've created this term for converting things to numbers, so I call it stringify. So yeah, stringify them. So number one, number two has been stringified. Now on that basis we have done a short circuit, that new number which is a string, now number one, which was a string, which is a string now, and number two, which is a string two now, has the same length or not. Like number of characters present in the string number is same or not. If not, then straight up return false. Why to compare in the first place? The entire logic is based like if they have the frequency is same. The very basic, the core idea of frequency being same is that the participating element should be same as well. Anyway, so we have created two frequency counters here and empty frequency. Oh yeah, basically two objects here: frequency counter one, frequency counter two. And I've used this traditional way of writing it, which is far more intuitive for me rather than writing that one hand line for that. So it basically checks like in the frequency counter for that digit if it is already existing, then what do you not need to do? Just add one to that. Add one to the current value of whatever is existing. And if it is not there, just straight up add that digit in the frequency counter, that empty array for the first run, and set it to one. Crazy. How crazy, I really put like 20 to 20, 10 to 20% because I remember the frequency counter, I guess that's why. So same do with the counter 2 object, that is the empty object 2, and similar concepts there. That's it. And debug, we'll check that, you know that from num1 and num2 we have created these things. So what is the output? We'll check that. Keys and value pairs made from num1 and num2, counter 1. So these are like filled with numbers now. After they are filled with numbers, we have to try doing this. You have to use let for for in loop. Right now you can see for in loop, so you can use counter one or counter two, anything here, but we have used counter one for intuitiveness. So if it says if the frequency counters key, basically of a certain key, for that very key the value should match. If the value is not matching, that is this frequency is more number of time, let's say 3 is 2 times in frequency counter 1 and 3 is 1 time in frequency counter 2. If they are not same, straight up return false, nothing will happen. It will just straight up return false here. All the processing in between will just get ignored. Okay, this was one thing. And another thing you need to add for, like, I'll show you why we need to add that, because I keep forgetting that, and that's how it kind of looks kind of weird, because like I don't know what does it even want to say here. This is the code. Let me just copy this and paste it in the VS Code. Okay, this one. This says additional edge case check if a key is not present in frequency counter. A unique key is there which is not present. And how did it even pass that length check? Yeah, length check could be passed. The above short circuit. Why? Because it just like, imagine there are like two boxes and they both contain like 12 oranges. So like instead of putting 12 oranges, one can put 11 oranges and put one paper wrapped ball and put it inside it and make it appear like an orange, right? But it is a unique ingredient, unique item in the box of orange, right? So but if you check the length, oh no, both of them are 12, so let's just let it go in. So that's what we are talking about. My English is really fucked. Anyway, so we check if that key in frequency counter 2, I don't know what it is doing. So we are just basically doing let key in the frequency counter 1. So we are just pulling out all the keys present in frequency counter 1. The first turn it took frequency counter 1, and basically it is also a short circuit here, checking that certain key basically is iterating. Okay, every time it is iterating. In sometimes the key present in frequency counter 1, okay, might not be present in frequency counter 2. That is the case we are searching for, and for that reason we are returning false. Still intuitive. I might again have to search it up every next time if I do deal with certain things. So let me just run it. Okay, control S to save, control shift Y and F5, and as you can see it is returning true. So let's just change the number. Let's do it 1111. How many fours? Zero. Well, how many ones? Four ones and 1 0. So again, we'll try to do 5 ones this time. Okay, and it should return false. It returned false. But if you just remove that extra edge case, oh god, why it is here? Extra edge case out of here, right? Let me just comment this out. It will return true. Not gonna lie. Okay, it's returning. Okay, why is it so? Okay, so it was unnecessary. I mean, might be wrong. Let's just make it two here. Okay, that was an extra. I'm sorry, I'm unable to. Maybe I have not understood it properly. That's why I'm unable to come up with some good answer. And at least it should return true. It's returning true. How can I make it look? How can I make? Okay, I'll ask ChatGPT this. Sorry, I'll come back after 1 minute. Wait. You know what? After having a long discussion with ChatGPT about what the fuck is the damn use of this extra damn line that checks if frequency of matching keys. Oh, no, no, not this one. This uh, comparing frequency without the key check. This above bullshit. Where is it? Where is it? Not this one. Basically, this line that if that matching the key, that all the keys are same in both the frequency counters. This is completely unnecessary. Okay, this is what, after proving it wrong multiple times with my results, not by like trying to make it a fool of it, but it says, in summary, the key check is not strictly necessary for the correctness because the frequency comparison will catch mismatched frequencies. However, it serves as an additional safeguard. I don't think how, but okay, it doesn't excellent. But basically, it can improve the readability by making it explicitly clear that all the keys of the frequencies counters must match. That extra safeguard we put it at the very beginning, right? That if the length is not left, if the length are not equal, that somehow serves the very purpose of checking if the keys are same in both or not. So you know what we'll do? We'll just chill. So it is working with and without this additional edge case checker. So we'll just keep it like that. Comment it out. So this was quite easy to build. I'll catch you up in the next video. Till then, be safe, take care, and keep BSing. Thank you, thank you, thank you.